We are on page 98 and we're going to start with the method. So the first one is the manual right here. Manual interval classification. You can define your own classification breaks. So, and then the next we have is the equal interval. So with equal intervals, the entire range of the data is equally divided by the number of classes you choose. If the range of value is 1 to 1000 and there are 5 classes, this method creates classes of 1 to 200, 201 to 400, 401 to 600, 601 to 800, and 801 to 1000. This method is useful for highlighting changes in extremes and is most appropriate for familiar data ranges such as percentage or temperatures. Using this method, it is also possible to have classes that contain no value. And then the second one is the defined interval. A defined interval is similar to an equal interval. However, you can define the interval size to determine how many classes there are. If the students in your class have a range of test scores from 50% to 90%, 50% to 90%, for example, and the interval size is 10, this method creates 4 classes. So 50 to 60, 61 to 70, 71 to 80, and 81 to 90%. The next one is quantile. With quantiles, all classes have the same number of features. This method is appropriate when data is linearly distributed. It can create a balanced looking map because no classes have too many, too few, or no values, but the resultant map can be misleading. The key is to increase the number of classes to prevent data from being placed in a different class. When an appropriate number of classes is used, the data can be visually presented more accurately. So the natural breaks, the Jenks classification. Natural breaks classes are based on natural groupings inherent in the data, and boundaries are set in spots in which there are relatively large gaps between values, developed by Professor George Jenkins of University of Kansas. This method is useful for classifying unevenly distributed data such as population. Geometric interval classification. The geometric interval classification scheme creates class breaks based on class intervals that have a geometric series such as a logarithmic distribution. This method was specifically designed to accommodate continuous data and minimize variance within classes to ensure that each class range has approximately the same number of values and that the change between intervals is fairly consistent. And the last one is the standard deviation. Data that you will know is normally distributed in a bell-shaped curve, and you can see from here bear-shaped curve, and can benefit from standard deviation classification. This method creates classes according to a specified number of standard deviation from the mean value. A divergent color scheme is recommended for this classification. And then we're going to create our own category that will be used to compare maps every year for which you have data. So right now we're going to compare values. They must be broken into the same range of the comparison. And in the color scheme, we're gonna do is color scheme classes. We're going to change from 5 to 4. And then we're going to choose yellow to red color ramp, yellow to red color ramp. Under class breaks, we're going to click the first upper value twice to make it editable and replace the existing value with 23. And then 24.1, 24.2, 27.7. Then we're going to enter the following upper value for the remaining three symbology category 27. Oopsies, it doesn't like it. 27. If it doesn't like it, then you have to retype it again. And then 31. Where is my next one? All right. 23, 27. Did I type anything wrong? 31. Then I need 35. Let's redo it again. Percentage. And then quantile. All right. And then I do manual. Okay. The first one is 23. 23. And then we have 27. Alright, this one is 31. And this one is 35. This should be 31. And this is 27. Alright, finally we fix it. Okay, if it doesn't like it, and then you have to retype it again. And now we notice that the new class breaks change your map dramatically. Most counties are now in the second lowest category because no more than 27% of their populations are considered obese. So no counties are in the highest category, which is reserved for which within one with more than 31% of their population considered obese. The higher thresholds are required to accommodate the higher percentage of subsequent years. You will soon see. So now we're going to import layer symbology. So now we're going to continue. So then we will have to do 2005. On the content table, we're going to copy this, and then paste. All right, and then we're going to do is go to 2005. All right, and then the same way that we have to identical layer earlier, but now we change it into 2005. So we keep the layer straight, rename the first one 2004. So we're going to do this 2004, and then this one will be 2005. And if you simply change the symbology field to show 2005 percentage value, the breaks you define either earlier will not be maintained. So instead, we will import the symbology scheme from the 2004 layer, but make it display the percent for 2005 values. So what we're gonna do is with 2005 select in table of contents, we're gonna go to the symbology pane and we're going to click option symbol, and then we're going to click cell. We're going to select first and symbology pane, and we're going to import. And now we have this window. Apply symbology from layer tool opens in the geoprocessing pane. We're going to keep the 2005 as the input layer. So then we have symbology layer, and then we will do 2004. And then we keep 2005 as the input layer that we select 2004, and the source field should already point to the obesity that percent, and then the target field, source field. And the target field we're going to change into 2005. Percent to 05. And then we're going to run. So, and we drag it a little bit and observe a little bit. So that we turn the 2005 layer on and off to see the difference between the years. Okay, now we're going to close, on and off, on and off, on and off. So that now you can see the number here already changed for us. And in terms of map colors, in 2005, 2 yellow counties have now advanced to light orange, and 3 light orange counties have advanced to dark orange. So this is 2005, 2004. 2004, 2005. So continue step 1 through 6, 5 more times. Paste 2004 layer and rename it. We're gonna do 2006 this time. 2006. Oh, copy and then paste, and then paste, and then paste, and then paste, and then paste. So we did 1, 4, 5, 6, 7, 8, 9, 10. All right, we have enough. And then this will be 2005, 2006. And then this will be 2007, 2008, 2009, 2010. All right, and then we will have to do the same. Go to symbology, and we go to the import, and 2006, the layer we're gonna do is 2004, but here we're going to change it into 2006 and going to run. And then you can see it changes for 2006. And then we will do 2007, select on it, and then import in 2007 and go to 2004 and change it into 2007. And then we will do 2008 and then go to select first and then import 2000 and then change it into 2008, %A, go to run, and then we will do 2009. We will do 2009, go to import, 2009, input layer, and then 2004. And target field, it will be 2009, and then run, %9. Okay. Oh, I have to change my 6. You see something wrong with my 6, all right? Go to import, 2004. And then this is %6, not number 6, run. And now it changes into %, %5%, okay? And then we have the last one, import, and go to 2004, and target will be %10, click run, there. Okay, so now we did everything.